Chapter 1, Reflection of Light at Curved Surfaces. Topic 1.7, Ray Diagrams for Concave Mirror. Now, what are ray diagrams? Ray diagrams are tools used for better understanding of concepts in optics. For example, see here graphs, charts, tables, photographs, pictures, and diagrams are used as tools for better understanding of concepts in science and mathematics. These are tools used for better understanding of the concepts in science and mathematics. Similarly, exactly similarly, now the ray diagrams, also known as the light ray diagrams, are tools used for better understanding of the concepts in optics. Now, what is the role of ray diagrams? Ray, what do they describe? Ray diagrams describe the movement of the light rays. Ray diagrams describe the path of the light rays. Ray diagrams also describe the behavior of the light rays. The ray diagrams also describe or explain the nature of the images, the location, size, and orientation of the images is better known with the help of light ray diagrams. Line is a long collection of points. Line extends in both the directions and line has infinite length. See here, it is extending in both the directions and it has infinite length. Now, line segment is a part of a line. Line segment is a part of a line. It does not extend and it has a fixed length. Now, ray is a part of a line. See here, this ray is a part of a line. It starts at a point and extends in one direction. Now, it has infinite length. Let's see here the light coming from the sun. We call them as sun rays because they start at a point and move in all the directions. And we do not call them as sun lines. Observe some concepts. A light ray, gravity, center of mass, intelligence, self-esteem, happiness, culture. These are concepts we believe true. They are existing, but we cannot directly observe. Such concepts are known as constructs, hypothetical constructs. So they are taken for granted. So we observe that they are true and their existence is taken by default. We believe that they are existing and based on these constructs, we develop other theories and we explain the other concepts. See here, a light ray is a hypothetical construct. Light rays are present in a light beam. That is the truth. But we cannot observe the light ray directly. So, light ray or a single light ray is a hypothetical construct. We take it for granted. Now, based on the concept of single light ray or light rays, we have ray diagrams in optics. Three rules are important while describing the ray diagrams for a concave mirror. Rule 1. A ray traveling parallel to the principal axis reflects through focus. Rule 2. A ray traveling through the focus reflects parallel to the principal axis. Rule 3. A ray traveling through the center of curvature, reflects back through the center of curvature. ray diagrams for a concave mirror. We have 6 ray diagrams for concave mirror. We keep the object at 6 different places and we observe the nature of the images observed at 6 different places. Let us observe the phenomena. See here. Now this is a concave mirror and this is reflecting part. Now the first position, we move the object from our right side to left side, that is we place the object at infinity at the first time, then we move towards the concave mirror, that is beyond c. At beyond c we keep the object, this is second position, and at the third position we keep the object at the center of the curvature, and at the fourth position we keep the object between the center of curvature and the focus, and the fifth position is we keep the object at focus, and the sixth position is we keep the object between the pole and the focus. Now, corresponding to these places, we observe the images like this. Now, we are moving the object from infinity towards the pole, from this side to this side, that is we are moving from right side to left side, that is we are moving from far away infinity place to beyond center of curvature, and we are moving towards the concave mirror. Now when we are moving like this, the object, when we are moving the object like this, now we get the image is moving from this place to this place, from left to right the image moves. See here, when the object is placed at infinity, that is very far distance, then we get a point size image. It is inverted, and point size, and it is real means we can catch it on the screen. Now point size and inverted, it is not a point, it is a point size, but if you carefully observe it will be inverted. So when the object is placed at infinity, we get a point size image, inverted image, and real image. Now the second one is we move towards the mirror. Now we keep the object at beyond the center of curvature, then we get image between the focus and the center of curvature. It is also inverted, but it is a little bigger than the earlier one. Now here it is diminished. Diminished means its size is, the image size is less than the object size, so it is diminished or reduced. So this is image will get between the focus and the center. That means here I will repeat, when the object is kept beyond the center of the curvature, we get the image, inverted image and real image and diminished image between the focus and the center of curvature. See here, we are moving towards like this, and image is moving from in this direction. Now the third point, very important, see here, we keep the object at the center of curvature. We keep the object at the center of curvature, and we will observe that we get the image also at the center of curvature. Here the image is inverted, but its size is equal to the object size. That means the size of the image and the size of the object is same. So here, now coming to the next position, let us keep the object between the center and focus O4, or object at the place 4. Now then we get same inverted image, but a little magnified image or enlarged image than the object. The image size is little bigger than or larger than enlarged image than the object. Now again, so when we are moving towards the mirror, where the image is moving in this direction. Now beyond the center of curvature, we get the image. Now coming to the fifth position, when we keep the object at 5 at the focus, when we keep the object at the focus, we get the image beyond at the infinity. We get the image at the infinite distance. Then it is also very large, or magnified image will get. It is also inverted image, and it is also real image. So here, see here, we are moving the object from right side to left side, and we are getting the image is moving from left side to right side. This is so up to the object for 5 places, this like this. Now at the fifth place, we have to remember, see here, when the object is placed between the focus and the pole of the mirror, when the object is placed between the focus and the pole of the mirror, we get image behind the mirror. We get the image behind the mirror, and this mirror, you see here, it is virtual and it is erect. It is virtual because it is behind the mirror, we get it, and it is erect image. We are getting erect image, and we get virtual image. So which is very much enlarged or magnified. So this is about 6 ray diagrams. Ray diagrams for concave mirror. We have 6 ray diagrams for concave mirror. These ray diagrams are drawn on based on the 3 rules. Rule 1 is related to ray 1. The ray 1 always starts parallel to the principal axis, always travels parallel to the principal axis, and reaches the concave mirror, and the reflected ray passes through the focus. And ray 2, rule 2 is related to ray 2. The ray 2, the incident ray is traveling through the focus, and the reflected ray travels parallel to the principal axis. Now the third type of ray is ray 3. So the rule 3 is related to ray 3 or R3. Here what is happening? The incident ray passes through the center of curvature, and after reflection also it passes through the center of curvature. See here, the R3 here, it passes through the center of curvature and also returns, or the reflected ray also passes through the center of curvature. This is R3. So we have 6 ray diagrams based on 3 rules. Now let us consider the first ray diagram. See here, when the object is kept at infinite distance, we get R1 type of rays. That means we get parallel rays from the infinite distance object, and these parallel rays fall on the concave mirror, and after falling we get reflected rays, and these reflected rays meet at a point, and at this point of intersection we get an image, and the image is point size image, and the image is inverted image, and the image is real image. The image is real because it is formed in front of the mirror, and it can be caught on the screen. See here, this is how we get this type of image. Here I1 means image 1 related to the first diagram, and O1 means object 1 related to the first diagram. This diagram is entirely based on the rule 1, that is ray 1. Now coming to the second diagram. Now here two types of rays are here. R1 the ray, and R2 is another ray. So rule 1 and rule 2 are followed here. Now the object is kept beyond the center of curvature. The object is kept beyond the center of curvature, and from there the incident rays are coming, the rays are starting from here, and R1 after reaching the concave mirror, the reflected ray is passing through the focus. The second type of ray, that is R2, is passing through the focus, and after reflection it is traveling parallel to the principal axis. Here at the intersection of these reflected rays, we get an image, and the image is inverted. The image is inverted and its size is less than the object size. So we call it as diminished image. So rule 1 and rule 2 are followed in this diagram, and we get image 2. Image 2 means the image related to the second diagram. O2 means object 2, that is object 2 related to the second diagram. So when the object is kept beyond the center of the curvature, we get an image between the focus and the center, and the image is diminished and it is inverted and it is real. Now coming to the third ray diagram, here also rule 1 and rule 2 are followed. That means ray 1 and ray 2, both types of rays are used in this ray diagram. See here, the object is kept at the center of the curvature. The object is kept at the center of the curvature, and R1 is the ray 1 is incident on the mirror, and the reflected ray passes through the focus, and another ray R2, the second type of ray R2, is passing through the focus and returns and reflects parallel to the principal axis, and after reflection, at the point of intersection of these two rays, the reflected rays, we get an image, and the image is inverted image, and the size of the image is equal to the size of the object, and it is real. See here, I3 means image 3 related to third object. O3 means object 3 related to third diagram. Now coming to the fourth diagram. Here, see here, we use rule 1 and rule 2 here. Now the object is kept between the center of curvature and focus. See here, the object is kept between the center of curvature and the focus. Now the ray 1 is incident on the center of curvature. The ray 1 is falling on the mirror, and it is returning, or the reflected ray is passing through the focus, and the ray 2 is passing through the focus, and after reflection it travels parallel to the principal axis. Now here, due to intersection of these reflected rays, we get an image. The image is inverted. The image is a little bigger than the size of the object. So here we get the inverted image, enlarged image, and real image. Now coming to the fifth diagram. Here rule 1 and rule 3 is followed here. There is no scope for rule 1. See here, the object is at F. The object is kept at F, and now at the F, now a ray is starting. R1 is the ray 1 traveling parallel to the principal axis, and after reflection passes through the focus. Now there is no scope for R2 because it is already at the focus, so the light ray cannot pass through the focus again. So R2 ray is not possible here. So we have R3 type of ray. The ray is starting at the tip of the object, and it is passing through the center. It is imagined so as that it is passing through the center of curvature, and it is returning through the center of curvature, and these two reflected rays appear as if they are parallel and they are supposed to be meeting at a far distance, at infinite distance. We consider that at infinite distance the image is formed. The image is very much enlarged or magnified, and it is inverted, and it is real, and it is obtained at infinite distance. See here one more type of ray diagram, the last ray diagram, the sixth ray diagram. Here also we use the rule 1 and rule 3. There is no scope for rule 2. See here, the object is kept between F and P. The object is kept between the focus and the pole, or else we can also consider that the object is kept at focus, between the focus and the mirror. So here what is happening, a ray 1 or a light ray is passing parallel to the principal axis and reaching the surface of the concave mirror, and it is traveling, it is returning back. Now we have one, there is no scope for R2 because it is already behind this focus, so it cannot pass through the focus. So we consider the ray 3, that is the light ray traveling from the tip of the this object, and it is falling on the center of the it is falling on the surface of the mirror, and it looks as if it is a normal, as if it is a normal, and the normal passes through the center of curvature. And these rays, because of these reflected rays, we extend them to the backwards, and we imagine that the object is the image is appearing behind the mirror, and the image is I6. The image is larger and bigger, or we can say the image is magnified. So the last case here, rule 1 and rule 3 are followed, and the image is behind the mirror, and it is virtual, and it is erect image.